me?
Hello, hello, hello. Yeah, yeah, hi.
Hi.
Yes, yes.
Hey Mohit, कैसे हो आप? How are you?
I'm fine, Arun. What about you?
Yeah, I'm also good. Yeah, thanks for asking. Okay, chalo, let's start. We'll start. Okay. By the way, do you mind if we extend this 7-day Google coding challenge a little bit, like in more days?
Arun, extend it as much you want. No worries.
Sorry.
Extend it as much you want, Arun.
Okay, then we'll extend it in days. Okay, chalo, let's start here. Uh, which topic? I think last time Mohit you mentioned something about graphs, right?
Yes, sir.
Okay, let's do graphs today because I remember we were not able to. So let's pick this. Okay, this is Dijkstra algorithm, a really important algorithm, and I don't think I have also, So let's. I think we should try doing this. I don't like this algorithm, by the way.
Arun, how to approach a graph concept? Because understanding itself, it is hard. Like a double linked list will comes into picture. A double linked list and 2D matrix.
So 2D matrix does come into the picture, but doubly
Okay.
linked list to no. I've not seen doubly
Um,
linked list coming.
maybe in the undirected graph, the you can use the 2D matrix, but I have used it
You can use
double
2D
linked list.
every which way, na?
Okay, okay, fine, yeah.
अनडायरेक्टेड हो या डायरेक्टेड हो वो तो दोनों में ही आप यूज कर सकते हो
Okay, 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 fine.
ना चलो इसको रिफ्रेश करते हैं आई डोंट थिंक आई हैव आल्सो डन इट इन द पास्ट ओह आई हैव डन इट इन 2020 सो okay let's try doing this now okay you have an undirected connected graph of n nodes labeled from 0 to n minus 1 you are given an array graph where graph of I is the list of all the nodes connected with node I by an edge return the length of the shortest path that visits every node. Okay, shortest path, length of shortest path that visits every node. You may start and stop at any of the node. You may revisit nodes multiple times, and you may reuse the edges also. Okay, makes sense. In this, how's connected graph of n nodes labeled from 0 to n minus 1? You're given a graph by is the list of all the nodes. Okay, okay, okay. Got it. So let's make a, this thing where we have now V, which is that matrix that shows which all edges do we have. Okay. Second, let's see the constraints also. So constraints are 12 only. Okay. So 12 into 12. How much is 12 into 12? At,
144.
at max 144 edges could be there. Hmm. And we have to keep the track of visited also, right? Hmm. So how can we keep track of visited? We can keep track of visited by
By keeping visited array.
visited array also. But why keep an array? क्योंकि उसमें you have to block. Rather, why not as an integer? How? We would right now the value of the integer could be 0, but let us say you picked the fourth element. Fourth note is visited now. So why don't we change the fourth bit to 1 from 0 to 1? Same ways now if you visited the second node, why don't we change the second bit as 1? This way we would be able to check that okay, total of n nodes are there, so so the final value should be n, like all the bits n bits should be 1, right? Yes or no?
You are talking with respect to bit notation level.
Yes, or yeah, that can help us
But the
keeping track
thing
of.
is, we don't know the every node will be start from zero till
Huh?
the n.
No, huh, huh. 0 to n minus 1 it is mentioned.
Okay, then it's fine because if the node number will be very that yeah,
Right,
okay.
right, it is mentioned here 0 to n minus 1.
Yeah, we can check all the ones are there or not.
Right.
From that we can conclude.
So let's take a queue because queue only using the queue we can do that, right? Uh, hmm, but how do we? Okay, let's just do it first. Q int. This is like the nodes wala thing. Distance and visited. ठीक है? First of all, start could be any, right? So for int I equals to 0, I less than v dot size comma I plus plus. ठीक है? Now nodes dot push your I distance dot push 0 and visited dot push your 0. ठीक है? Now while your not nodes dot empty, ठीक है? What we will do here is int current node equal to nodes dot pop, int current distance equal to distance dot, oh sorry, distance nodes dot front. Distance dot front current visited equals to visited dot front. Okay, now let's pop all of these. So nodes dot pop distance dot pop visited dot pop. ठीक
We
है?
are going with the breadth first search, Arun.
Yeah, because that gives the shortest, no?
Okay.
Yeah, it is always said that breadth-first search always gives the shortest.
How to identify whether we can go with the approach of breadth first search, depth first
This
search?
is the only thing. If you want to find the shortest, so you always have to go with the breadth-first search. Okay? If current visited equals to 1, this thing should be graph dot size -1. ठीक है? It means that we have arrived and we have to return current distance. Okay. Otherwise, what we have to do is then push all the nodes back again. I equals to 0, comma I less than v of current node dot size, comma I plus plus, if equals to current node continue. Okay, हमने अभी तक edges बनाई नहीं है, so we'll make the edges also. The next thing is now you have to check. So if your v of I current node of I equals to 1, then only you have to push it back, which means nodes dot push I distance dot push current distance plus 1 and current visited dot push, no, visited, sorry, dot push current visited or this thing by ith position, right? Because we are doing the ith wala visited now, right? Otherwise, return 0. Make sense? We just have to now build the edges. So for int I equals to 0, I less than graph dot size, comma I plus plus, j less than graph of I dot size, comma j plus plus, v of I, comma graph of I, comma j equals to 1. ठीक है? I think reverse is also good now. No, I think reverse वाला ठीक है. I think reverse is also good to go. ठीक है. Shall we run it? Let's try to run it. Oh, wow. But we are close though. Okay. How much is the difference? Expected is 4, but the answer is like, okay, 1, 2, 3, 4. 1, 2, 3, 4. Is it the case where we are always going to get like current distance? Shall we try doing this? Return current distance minus 1. I think both the test cases would pass though. Yeah, these things would pass, but I think it should break here though. Oh, time limit exceeded. By the way, 40 test cases passed, which means, yeah, we have to optimize somewhere. Optimization is needed. I think we are repeating a lot of test cases and we are not making use of this thing. What do you say? This visited, huh? I think we should make use of visited also. How can we reduce the number of cases that we are doing or going via our visited? Let's think. Guys, everyone is on the same page or not? Hello. Everyone seems drowsy, sleepy. Hello. Are you guys able to hear me?
Yes, sir.
Yeah.
Is able to hear. Yes, yes.
Okay. But you guys are not interacting. Why is it so? We are getting time limit exceeded error, yeah. Why is this so? We should not get
Because
that.
of number of node increases in the maybe that
Yeah,
test case.
but that is like, yeah, you're right about that. How can we use visited to reduce the number of cases?
Instead of int, can we use it with long for the queue creation?
But how would it help? Think like changing it to long. How you can change it, but that is not the issue, na.
I
Issue to int में 32 bits can be stored.
Mhm.
So we to just need 12 na, it is written देखो 12.
Okay, okay, fine.
हाँ, but issue तो time limit exceeded का है ना, which means we are going over the cases multiple times, right? We are going over the edges multiple times. Uh, how to fix it? How to fix it? How? Think. How to fix it? We are missing something. I don't think we are using visited judiciously. Hmm, how to make use of visited? I don't think we are making use of visited any which way. We are not making use of visited actually. We are making use of visited only to calculate if we have visited all the nodes or not. We are not making use of visited in any which way. And this is a hard problem. Hmm. What is stopping us? Like, okay, came to 0, it of course came to 1, it would have. We said कि 0 को ले लो. Okay, if hmm, if a particular node is already visited and that is not connected to any other node, that is only having one node as the connected one, don't you think we should forgive that? Now what does this mean is, if current visited and is equals 1, and one more thing, graph of I dot size is less than equals to 1, in that case we should not you know consider that. Okay, okay, lower precedence, okay, got it. So graph of I hmm, now let's try to run it. This will obviously reduce a lot of test cases though. Time limit exceeded again. Okay, let's see if I've done this in 2020. Let's see how did I do it. Okay, this is like creating the edges. Unordered map. I'm taking Q. It is the current nodes and the length. Okay, हो गया. While current, ठीक है, current node लिया and length लिया. If my current nodes or slash oh, okay, long key is current node into 37. Okay, this is the current node. And current nodes into 31. This is a key that I have created. If current nodes equal to power 2 comma graph dot size minus 1 current return current length current I equals to 0 I lesser than graph dot size. I don't know what am I doing here, like why am I doing this. Current nodes हो गया. I think current nodes में we are marking the visited wala thing. Then I'm creating the key current node into 37 plus. Okay. Hmm. Hmm. I think I got what I was trying to do previously, though. So basically, the new key that is being formed is whatever your current visited nodes are, and then you're trying to go to one more node. Like situation is this is the visited part, and now you are trying to come here again. So this plus this situation should be unique all the time. Guys, contribute here. Why are you so silent today? Hello. Where is everyone? Mohit, Sri Parno, why are you so silent? Pradeep, Tarun, why are you so silent today?
Actually, I'm not understanding a few things.
So why are you
I
not
joined. I joined really late again.
okay?
Yeah, nowadays I'm getting so late after office.
Arun, for me, always if it is new problems, it becomes headache. Like suddenly I got headache, like while thinking or something. I am understanding with your code.
Mm-hmm. Sri
Can
Parno?
you tell me in short, Arun, what are we doing?
Yeah, sure.
Really, two to 3 minutes.
Sure. Sri Parno, are you there? I think he would be busy in some meeting. Point is that you have to find the minimal path so that all the nodes get visited. This is the case.
Hmm.
बस ये like ये question है.
Yeah, and what are we doing to solve this?
So what we have done is we have taken three queues,
Hmm.
node, distance, and visited,
Hmm.
and then we are applying breadth first search over there.
Okay.
Yeah, there's just one thing that we can do. This is a map.
Mm-hmm.
Now,
Arun, I'm here.
okay.
Sorry. No, my mom is sick, so I was looking at her.
No worries, no worries, no worries. So if my
Hmm.
current visited into 31 plus current node into 37, map dot find
Sabad.
equals to map dot end, then we should continue. Oh, not equals to. इसको यहाँ किया जाए, यहाँ ले लेते हैं, ठीक है. Now which means that this is a unique case, so map of this thing equals to 1. Now I think this should run fine because I've removed now the thing that we were missing. Yeah, all the cases passed now. Yeah, it also passed. Perfect. Mohit, you understood? Ki nahi? Hello. Mohit, you there? Mohit, you are on mute if you are saying something. I think he's also gone. Tarun? Kedarnath?
Yes, yes.
You have understood, Tarun?
Yeah, yes, yes. I need to practice it, but yeah, I understood.
Yeah, this is a very good question though. A very tough one also. But yeah, okay. Let's mark it as done. I think, mm, you know, okay. Do you want me to pick a slightly easy questions?
Yes,
Um,
sir.
Sorry?
Yes, yes, sir.
Yes, okay.
why is he?
I think who was this वैसे?
Pradeep.
मतलब easy as in कि यार थोड़ा सा out of practice तो नहीं हो गए हैं, 2 दिन हमने किया नहीं है, तो एक बार back in shape आने के लिए.
अच्छा.
I don't know. Can you share the problem? I'm back.
हाँ ना, क्यों नहीं?
Hmm.
I will share here.
Thank you.
So if we just pick some easier question, then we won't stop there, right? We will take some other as well.
Who was this? Pradeep?
Pradeep.
Pradeep, it is not about the which problem statement we are picking. It is about are we able to get into the right shape where we want to be or not. Because I can give you easy problems and I will make sure, because I have actually seen it and you would not be able to solve it.
Hmm.
And I've seen hard problems which get solved within minutes.
Hmm.
So do not judge a problem by this tag कि easy है या hard है, सच में.
हाँ वो
Okay.
भी है.
हाँ. Because this was a hard problem and we have been stuck at easy problems also. ऐसा नहीं कि हम लोग नहीं हुए हैं. हम लोग होते हैं, सब होते हैं, इंसान है भाई.
हाँ.
So let's try doing this. This is also graph का ही problem. Let's
Hmm.
try doing this. Frog. Okay, this is also hard problem. Let's see. Given an undirected, should we see if I've done it in the past or not?
Yeah.
2020 में ही मैंने किया हुआ है.
2020 was your year.
Yeah, and this is like in 4th attempt it was passed.
Hmm.
Okay, given an undirected tree consisting of n vertices numbered from 1 to n, a frog starts jumping from vertex 1. In 1 second, the frog jumps from its current vertex to another unvisited vertex if they are directly connected. The frog cannot jump back to a visited vertex. In case the frog can jump to several vertices, it jumps randomly to one of them with the same probability. Otherwise, when the frog cannot jump to an unvisited vertex, it jumps forever on the same vertex. The edge of the undirected tree is given in the array edges where this thing, okay, means that there exists an edge connecting the vertices. Return the probability that after t seconds the frog is on the vertex target. Okay.
Okay. Okay.
So we have to find the probability, right? So th- what should be the case? The case could be, let's try finding out at what all places can the frog be. And उसमें से we will see that how many positions are target divided by all of them, right?
Right.
So vector int finals. ठीक है? Let's move to our helper.
Can we just check the constraint once?
So how would that help you out? Of course.
It helps me sometimes.
Hmm. Let's just create that matrix. We'll just copy paste the code थोड़ा सा. ये वाला ले लेते हैं. Vector of vector int v and equal to n. ठीक है. Edges dot size comma I plus plus v of edges of I comma 0 equals to 1, and we have to do the reverse also. Oh, this edges of I comma 0 and v में भी तो वो वहां जाएगा ना. Edges of I comma 1. ठीक है ना. बाद में इसको बस रिवर्स कर देंगे. जीरो. एक सेकेंड. Now what we have to do is we have to take a visited also, no? है ना. तो visit,
Arun, are you more comfortable with this adjacency matrix?
yeah, this is not adjacent adjacency matrix because it helps actually and me in visualizing. Secondly, not just to me but adjacency matrix में अगर if I have to tell you कि यार now I want to find all the adjacent nodes of 2. Now अब होगा क्या कि you have to iterate on this complete edges वाला thing, right? Rather than doing that, why don't I just iterate on जो भी 2 के adjacent में है.
Okay, but adjacency matrix, I guess we need to run through all the nodes, right,
Yes.
and check if there exists an edge.
वो तो ऑफ कोर्स इसमें चेक करने की जरूरत नहीं एग्जिस्ट कर रहा है कि नहीं कर रहा है. वो तो एग्जिस्ट होगा तो अपने आप यहाँ पे मार्क हो जाएगा. समझ रहे हो ना.
Why don't adjacency list and
तो अगर लिस्ट से करना है आप लिस्ट से भी कर सकते हो. विजुअलाइजेशन में मुझे ये एक्चुअली हेल्प करता है. मेरे एक्सपीरियंस में आई थिंक मैट्रिक्स इज समथिंग दैट इज बेटर इन माय ओपिनियन. बट अगेन लिस्ट से भी हो जाएगा. वो तो लिस्ट से भी हो जाएगा. इट्स नॉट दैट बिग ऑफ अ डील एक्चुअली. ठीक है. map int comma bool, and this
In
becomes
terms of time complexity, which one is better around there?
both are same. Adjacency matrix maybe what you're doing is you're iterating on all the edges. Udhar pe list maybe you're iterating on all the edges, so it is same. Helper, and what we'll do is we will try to now find all the things, right? So what all things do we have to pass? T we have to pass, target we have to pass. इसमें क्या मेंशन किया हुआ क्या? Are given in the array edges. A frog jumping from vertex 1 in 1 second. Acha, acha. So it will always start from vertex 1 only, right? This is like here. And let's pass in map. Okay. And we have to pass in finals also, no? Finals. Void helper int time, t is time, int target, then one is int current node, then there is this map, and then there is finals. So okay, if your time is equals to 0, now what you have to do is you have finals dot push back your current, and then you will have to return. Okay, this is one thing. Now your time is not 0. So what you have to do is you have to now iterate. Okay, so for first of all mark this node as visited. So current equals to 1. Okay, now for okay, you have, if you have any kids possible who have not been visited, then what you're going to do is you're going to go on to that node. And if you do not have any of the kids who are not yet visited, so you will have to stay right there, right? So let's say we will take a flag and we are saying that there are no kids that are left, but int I equals to 0, I less than, okay, we have not passed in v now. We also we have to pass, which is the edges. V of current dot size comma I plus plus. Okay. If your V of current comma I is equals to 0, then to continue. Now it is equals to 1. So now we have to check if I is already visited or not. So if map dot find, what do you have to find? I is not equals to map dot end and map of I equals to 1. Then also you have to continue. Lastly, now the last thing is now you are on a certain node which is not yet visited, right? So first of all, flag को 0 mark कर दो. And you have to pass it going forward. So helper time -1, comma target तो target ही रहेगा. Current becomes your I. Map is map. Finals is finals. And V is V. ठीक है? Now, finally, just check if your flag is equals to 1. Still, कोई बच्चा है ही नहीं इसका जो विजिट नहीं हुआ है, which means that this is your final, right? And so you're going to stay right here and you're going to keep on jumping, right? So what we should do is, this is your final, right? So finals dot push back your current and yeah, I think this should be it. और तो कुछ नहीं कर सकते. Map of this current equals to 0 and we will finally return. Because wait. Yeah, I think yeah, we can keep it return now. कूल है. आई थिंक इससे सारे के सारे वो विजिट तो हो जाएंगे, सारे पाथ्स विजिट हो जाएंगे. नाउ लेट्स सी, हमारे पास फाइनल्स आ गया है. तो हमारे पास फाइनल वैल्यूज तो आ गई. सो लेट्स सी हाउ मेनी ऑफ देम मैचेस द टारगेट. सो int n let's say equals to 0. So for I equals 0 comma I less than b dot size, meaning finals dot size, comma I plus plus. If my finals of I is equals to target n plus plus. Okay, now we have to return n into 1.0 divided by finals dot size into 1.0. ठीक है? Let's try to run it now because this is the probability. Okay, 47 line पे subscripted value is not an array or a pointer.
अब वो स्क्वायर ब्रैकेट्स डालना रह गया है बीच में.
ओ अच्छा, ठीक है, यहाँ पे रहेगी ना.
Right. Yeah.
ठीक है, now let's run it.
Next line also, Arun.
Oh yes, thank you. Yeah. Okay. What is the Shriek definition of n? अच्छा, oh okay. नम कर देते हैं इसको भी नम. Okay. So if you see, we are getting one case as right, जिधर पे it's 0.33, but इधर पे we are not getting. This is, I think, the first test case, no? 1,2, 1,3, 1,7. Yeah, this is the case where t is equal to 2 and target is equals to 4, right? It is my output is coming out to be 0.5, whereas the real output is 0.16. So the figure shows the given graph. The frog starts at vertex 1, jumping with 1 by 3 probability to vertex 2, and jumping by 1 probability to vertex 4. There's the probability for the frog is 4 after 2 seconds is going to be this thing, right? But what all could be the possibilities? Possibilities could be 1, 2, 1. Okay, let's print actually कि finals में आ क्या कह रहा है ना? Finals of I and L, because this will help us to debug. Okay, after 2 seconds, one could be 4, सही है. Another could be 6, ये भी आ सकता है. Could be 5 आ सकता है. Could be 7 आ सकता है. But what is this saying कि 1 by 6 और कौन से दो पोजीशंस है जो हम मिस कर रहे हैं? What do you think?
7 कैसा है वैसे?
अगर आप एक बार इधर पे जाओगे तो वापस नहीं जा सकते.
अच्छा अच्छा, ओके ओके.
You have to keep on jumping.
और वो टाइम अपना बढ़ता चलेगा.
हाँ, मतलब लाइफ टाइम तो वहीं पे you would stand.
Arun, I think the approach that we used is wrong.
Why?
What we calculated is 4 is possible. 4 is the possibility. Total outcomes are 4, 6, 5, and 7. 1 by 4 is the thing that we calculated.
हाँ.
But the question is like the probability for getting into 2 is 1 out of 3. And the probability for getting into 4 is 1 by 2. So 1 by 3 into 1 by 2 is 1 by 6.
Right. But you're right about that part also. But इधर पे भी what are we doing wrong? क्योंकि या तो हम कोई केस मिस कर रहे हो. अगर 1 by 6 आ रहा है मतलब टोटल 6 पॉसिबिलिटीज हैं एंड एक उसमें से 4 है. यस और नो?
Yes, yes.
तो अभी गलती कहाँ हो रही है? वी हैव टू फिगर दैट आउट आल्सो, नो? वो कौन से केसेस हैं दैट वी आर मिसिंग?
I think that target need not be the leaf node.
No, nothing is a leaf actually. Don't think of it like a tree. वो दिखने में भी ट्री लग रहा है बट वैसा वो है नहीं. वो डायग्राम ऐसे हो रहा है तो इधर लीफ का तो कुछ लेना देना नहीं है एक्चुअल में. इफ यू सी हम लोग टाइम को जीरो कर रहे हैं एंड नॉट कि उसका कोई और नोड है या नहीं है.
या
है ना. तो और इधर लीफ की बात इसलिए नहीं क्योंकि डायरेक्टेड नहीं है ना ये ग्राफ. ट्री इज अ डायरेक्टेड ग्राफ. तो इसके कोई किड्स नहीं है बट इसका तो है विच इज व्हाट 2. राइट.
या
Otherwise, there is other approach. ये वाला वो भी हम कर सकते हैं जो आपने बोला ना. उसमें भी
एक्चुअली एक सॉल्यूशन मुझे जो लग रहा है अरुण, अगर वो मैं बताऊँ
बताओ.
तो जो अपना टारगेट नोड का जो भी पाथ होगा, जैसे कि यहाँ पर है 1 2 और 4, राइट,
हाँ
ये अपना पाथ है.
हाँ
तो उस पाथ में जो भी नोड्स है
हाँ.
और उनके जो भी नंबर ऑफ एडजेसेंट नोड्स है उनको अगर अपन मल्टीप्लाई करते चलेंगे ना, तो अपन अपने आंसर तक पहुंच जाएंगे. जैसे कि अगर 1 के एडजेसेंट नोड से 3, तो वो 1/3 उसका प्रोबेबिलिटी आ जाएगा 1 से जंप करने का, और 2 पर से जंप करने का प्रोबेबिलिटी आ जाएगा 1/2. तो उनको अगर मल्टीप्लाई कर दे तो
नहीं वो तो
यस
आ
वी विल
जाएगा.
जंप.
आपकी बात तो सही है. मैं तो वो भी वो वाला अप्रोच भी कर लेंगे. बट इसमें क्या गलती है मेरे को वो भी नहीं समझ में आ रहा है. व्हाट्स रॉन्ग हियर. मतलब यू आर राइट बट इधर पे भी टोटल ऑफ 6 पॉसिबिलिटीज कुड बी देयर अकॉर्डिंग टू दिस थिंग. 1/6 तो तभी हुआ. जस्ट इमेजिन. तो हमारे आंसर में 4 possibilities are coming which we can see. Where are those 2 missing? Because अगर हमें वो समझ में आ गया ना हमें पूरा अप्रोच चेंज नहीं करना पड़ेगा. हमें वो 2 ही रखने हैं. फिर 2 और ऐड करने हैं. Okay, let's see. A frog starts jumping from vertex 1. In 1 second, the frog jumps from its current vertex to another unvisited vertex. If they are directly connected, a frog cannot jump back to a visited vertex. In case the frog can jump to several vertices, it jumps randomly to one of them with the same probability. Otherwise, when the frog cannot jump to any unvisited vertex, it jumps forever on the same vertex. Okay. तो आई थिंक इसको फिर उस तरीके से भी कर सकते हैं. इसको क्यू से भी कर सकते हैं बाय द वे. फिर तो कैसे? जस्ट सी दिस. क्यू यू ई int this is nodes then time and then probability. ठीक है. nodes dot push आपका फर्स्ट पे तो फर्स्ट ही गया. time dot push 0 because right now you are 0 and then probability dot push अभी पे 1 है probability. ठीक है. while not q dot empty. q नहीं यहाँ पे nodes. And what we can also do is we will have to keep a visited array also, no? इसमें क्या कोई साइकिल बन रहा है क्या?
ट्री में कैसे साइकिल बनेगा? अनडायरेक्टेड ट्री है ना?
हाँ तो अनडायरेक्टेड ट्री तो ग्राफ ही हो गया ना, साइकिल तो बन ही सकता
नहीं नहीं
है। ये दोनों कनेक्ट कर दिया। अच्छा पर
नहीं
वो
नहीं,
ट्री बोल रहा है, ट्री बोल
ट्री
रहा
का तो कंडीशन ही वही है ना कि साइकिल नहीं होता।
है। हाँ ट्री का तो वही है, बात तो सही है, बात तो सही है। तो वी आर ऑलवेज गोइंग डाउन ओनली, राइट? ठीक है, फिर तो विजिटेड की आई डोंट थिंक नीड है। ठीक है, हाँ विजिटेड की नीड तो है।
Actually, parent will also work if you just track the parent.
मतलब
A frog can only go to its parent, right? At most to its parent. तो
बट
अगर अपन ने,
पेरेंट पे कहाँ से जाएगा? पेरेंट पे तो नहीं जा सकता ना।
हाँ
अगर
वही तो
वन पेरेंट
विजिटेड विजिटेड में से तो अपन बस यही चेक कर रहे हैं ना कि पेरेंट है कि नहीं।
है, किड्स है कि नहीं, पेरेंट नहीं किड्स।
हाँ
ये तो
जो
किड्स है
भी है।
ना,
हम्म।
है ना?
एनीवेज, लेकिन विजिटेड और पेरेंट दोनों से ही काम चल जाएगा।
मतलब आप इनको बाप बोल लो।
हाँ
हाँ, चलो ठीक है, हम वैसे विजिटेड एरिया ले लेते हैं। स्कोर मैप इंट कॉमा बोल मैप, ठीक है ना? int current node equals to nodes dot front int current time equals to time dot front int current probability equals to probability dot front, ठीक है? So nodes dot pop time dot pop probability dot pop, ठीक है? Now if your current time is greater than t, तो then you should stop, right? तो कर दो continue. This is one. Second, if your current node equals to target, then you will have to return current probability, ठीक है? सेकंड ये हो गया। थर्ड is now you have to think of the kids, right? तो map of this your current node equals to 1, सबसे पहले तो ये कर दिया। नाउ फर्स्ट लेट्स फाइंड आउट कि इसके कितने बच्चे हैं, ठीक है? सो num equals to 0 for int I equals to 0 comma I lesser than, okay, we should mark this here, no, इतने को वो करते हैं, edges of your current node dot size ठीक है if your not edges बल्कि v ना current node of I equals 0 तो continue or map dot find I is not equals to map dot end तब भी continue नहीं तो this node is either 1 नहीं और तो नहीं होगा and होगा ना ठीक है now this thing is not visited also and it is 1 also right तो we will put it तो first of all num तो plus plus हो गया right Hmm, your nodes should push this thing I also and bus I think this is good to go now when you are nums plus plus भी हो गया which means you have found out कितने kids हैं तो times को भी update कर दो और probability को भी update कर दो equals to 1 कितनी बार होगा वो कितने values डलेंगे num times ठीक है ना तो time dot push current time plus 1 and probability dot push current probability into 1.0 सॉरी इसको डबल ही ले लो QUE डबल प्रोबेबिलिटी इसको भी डबल लो इसको 1.0 डाल दो ठीक है सो करंट प्रोबेबिलिटी डिवाइडेड बाय योर num into 1.0 ठीक है if all the cases are passed then return 0 perfect now let's try to run this okay ओके अब तो और छोटा आंसर आ रहा है चलो 0.33 1 by hmm, if my current time greater than हो क्या है तो करंट प्रोबेबिलिटी मैप इसको विजिटेड कर दो आई थिंक एक या दो केसेस फंस रहे हैं बस. Not more than that. So I think we'll figure this out later. We're already time. Chalo. Okay, guys. I think we only 3 or 4 folks are there. We'll figure this out, okay?
Yeah, okay.
Sure.
Chalo. Bye bye.
Bye.